Hello, I'm Damani Turner-Ward, an early career artist and undergraduate student at the University of West Florida studying biology and studio art. I completed this project in collaboration with Professor Thomas Asmuth, a transdisciplinary new media artist who has presented work at past iterations of the symposium. This project focuses on data visualization as a part of the STEAM movement, the disconnects that occur between scientific studies and the communication of the results, and potential ways to bridge these gaps with interdisciplinary practice. Our in-progress sculpture, Planes, works to improve data communication by reflecting field, lab procedures, and data in a single physical object. This methodology draws primarily from the philosophical concept of multiplicity and the field of phenomenology. The overarching goal of Planes is to act as a communication catalyst that bypasses noise present in many other data communication devices by blending information and dynamic context. Creating a data sculpture in this manner accomplishes two things. It improves data communication to a general audience by offering more fully integrated cues for interpretation, and it offers scientists the opportunity to examine their data from a new perspective. While Planes communicates the findings in an informational design similar to infographics, interactive displays, and so on, the spatial object also intends to reconnect the phenomenological with the physical. As a whole, this is an effort to reconcile the three individual worlds of field experience, data analysis, and information in order to reach a true episteme that cannot be achieved without all three of these other worlds working in tandem. This artistic expression is framed in terms of Deleuzian virtuality and actuality and mirrors a phenomenological analysis of science that identifies a divide between the perceived nature and the cognitive construction of the world, rooted in personal bias, shapes, experience, and understanding, tying this project conceptually to one of the symposium's themes. This sculpture, as a type of graphing interface, challenges the conceptual pitfall that scientific data encounters when removed or excised from the phenomenological experience in this manner. So, this is our maquette. Planes utilizes three translucent panels set into parallel slots atop a hollow base. Our proposed full-size iteration occupies a space around 1 meter in width, 45 centimeters in depth, and 60 centimeters in height. Each panel is animated with color transitions that reflect datasets as a field of shifting hues and brightness, using edge lighting with a stochastic pattern laser engraved across each of their faces. The hollow base contains a governing Arduino microcontroller and a strip of addressable LEDs aligned along the bottom edge of each plane. Each LED strip is controlled individually so that various aspects of the dataset can be demonstrated simultaneously, one on each plane. The environmental data represented in Planes comes from a study of the Pensacola-based system conducted by Nate Wynn. The dataset demonstrates concentrations of nitrate, nitrite, and phosphate found in pore water throughout a vertical plane of sediment perpendicular to the shoreline at the site on the Pensacola Bay. It is valuable to monitor the presence of these nutrients in the Pensacola Bay system because they strongly contribute to eutrophication, a global issue that is particularly concerning in watersheds bordered by agricultural and industrial activity. Eutrophication involves excessive bacterial growth due to an overabundance of nutrients and leads to widespread plant and animal death due to hypoxia, or lack of oxygen, and other resulting environmental conditions. The source of this artwork's data is one of many ongoing projects assessing the health of this system. In Pensacola, issues related to eutrophication, such as fish kills and seagrass bed loss, have been reduced but not resolved by the enforcement of the Clean Water Act and would likely be easily exacerbated by increased introduction of pollutants. The next step for this project will be constructing the actual artistic work, which we hope to do this fall. As we create this piece, we will continue experimenting with both form and code to explore the numerous possibilities for representing the environmental data within this piece, emphasizing variables such as time, location and space, and concentration in turn. This project would not have been possible without the support of my incredible collaborator and mentor, Thomas Asmuth, as well as the University of West Florida Office of Undergraduate Research. Thank you to the ICEA Organizing Committee for the opportunity to share our work, and thank you to Cynthia Turner for helping me edit this presentation. You can learn more about the work Asmuth and I have done by finding our poster proposal in the symposium proceedings under the title Resurrecting Data as a Phenomenological and Spatial Object. Please contact us if you have any questions, if you would like to discuss the intersection of art and science, especially in the realm of data visualization, or if you have interest in collaboration. Thank you for watching this presentation and enjoy the rest of the symposium.